Let's talk about surface area. So finding surface area of 3D solids sometimes can be a challenge, especially when it's a composite figure, which means it's composed of different figures. So for number 13 here, you can see this is a right solid whose height is 12 centimeters, and we are asked to find its surface area. So let's get started. The surface area is always pretty much for a prism. This is a prism because it's got a base at the bottom and a base at the top that are identical. So surface area of a prism is pretty much always the same formula. It's 2 times the area of the base plus the height of the solid times the perimeter of the base. And so the first thing we would need to do is find the area of the base. So the area of the base in this case is kind of a weird thing because it's like a half circle here and then a smaller half circle here. So starting with the bigger half circle, it's just going to be pi r squared over 2. So that would be 225 pi, because 15 squared is 225 pi over 2. And then I would also have to add the other half circle. The area of this half circle would be 100 pi over 2. 100 pi over 2. I could write 50 pi if I wanted to, but I'm going to leave it here, and you'll see why. So this is the area of the base so far. It's not simplified, but that's okay. I'm just going to write it like that for now, and that's in centimeters squared. So now I'm going to replace this here with the area of the base with what I've calculated. So I have actually 2 times 225 pi over 2 plus 100 pi over 2. Now let's add the other elements. So the other elements include the height, and the height is 12 centimeters. It's given to us, 12 centimeters, times the perimeter of the base. So the perimeter of the base, I'm going to put brackets here because I have to calculate a couple things. So when I look at the perimeter of the base, I need to add a couple things. I need to add the arc length of this half circle, the arc length of this half circle, and then these 2 little straight pieces here. So how big are those little straight pieces? If you look at the radius of the smaller circle, it's 10, and the radius of the larger circle is 15. So that means that the straight little pieces are each 5. So I'm going to go ahead and put 5 there, and then I'm going to add the other semicircles. The arc length of the semicircle here is just 15 pi. And the arc length of the smaller semicircle here is just 10 pi. So again, I haven't simplified or added like terms yet. I'm just kind of writing down what I know. And we always want to be careful with the calculation aspect. So now as we calculate using the surface area formula, you'll see that the 2 here, the 2 times area of base, is going to cancel here. So I have actually 225 pi plus 100 pi. And once I distribute, I can drop the parentheses. So I can go ahead and add like terms before I distribute. 15 pi and 10 pi is actually 25 pi. And if I multiply 25 pi times 12, I'm just multiplying the coefficient, of course. 25 times 12 is 300. So we took care of that, and then 12 times 5 is just 60. Right? So now we can add all of our like terms together. So we have 225 plus 100 is 325. Plus another 300 is 625. I actually just realized I made an error. So sometimes we have to find our errors and fix them. This is 5, this straight line is 5, and this straight line is also 5. So when I was multiplying by 5 here, I should have been multiplying by 10. So instead of 60, this should actually be 120. So again, it's really easy to make mistakes on these types of problems. So good thing I caught that mistake. And then we have centimeters squared. And that's it. Since these are not like terms, we leave our answer just like that. So surface area can get kind of complex depending on the shape. This next shape, you would just simply use the same formula, 2 times area of base plus the perimeter of base times the height. But let's do one that's a little more complicated. So looking at number 15 here. This is quite a scary one for students because sometimes they see this square root and they freak out, but it's okay. So find the surface area of the solid. So the surface area is the same formula that we just saw. So surface area equals 2 times the area of the base plus the perimeter of the base plus height times the perimeter of the base. So starting with the area of the base. So I'm going to go with the formula 2 times the area of the base. So I'm going to put some big brackets here. The area of the base is actually going to be the sum of this trapezoid and this semicircle. So the trapezoid, the area of the trapezoid is the height, which is actually 20 because this is 10 and this is 10. So the actual diameter of this circle is 20. So I say 20 times the sum of the bases. We know the area of the trapezoid is the sum of the bases times the height divided by 2. So that would be 39. 39 divided by 2. Plus the other part of the area is this half circle. So that would be 100 pi over 2. Or just 50 pi if you want. So we got this part of the formula done. Now we need to do the perimeter of the base times height. So the height is 12, that's given to us. And then the perimeter of the base is just the length of all the sides added together. So we have the square root of 761 for that diagonal side. And we can't really add or subtract that with anything because there are no other radical expressions. So we have the square root of 761 plus 10 plus 29, which is 39, plus the half circle, which is going to be 10 pi. So now all we have to do is simplify. No big deal, right? So we can start to cancel a couple things over here. This 2 and this 20 would cancel, so I would have 10. So I'd have 390, and 390 times 2, which would be 780, I think. $390 times 2 is, 780. And then 2 times the 50 pi, if I distribute here, I get 100 pi. Plus, now I can distribute this 12. 12 times the square root of 761. I can't really simplify that, but I can put the 12 as a coefficient. And then 12 times 39, which I'm too lazy to do in my head, so I'm going to do it with a calculator. I get 468. Okay, and then 12 times 10 pi, which is just 120 pi. And then my final step will be just to add like terms. So 720 plus 468, I can add those and I would get 1248. And then I can add my pi terms, which would be 100 pi plus 120 pi, which is plus 220 pi. And then I would add my radical symbol, which there's only one of them. That's 12 times the square root of 761. And then parentheses and units are centimeters squared. So that's it. So that's it for surface area.